welcome back. This is the second day of the R Bootcamp, and today's presenter is Eric Kawauchi. He's a postdoc here at Keck, at preventive medicine, and he's going to be talking about data wrangling, which is a very important theme that I think that a lot of people go into R because of it. So yeah, that's it. So go ahead, Eric.
Cool. Awesome, thank you. Thanks for the introduction. Let me just start my slides again. Yeah, so as George said, my name is Eric Kawauchi. I'm currently a postdoc here in the Division of Biostats. I did my PhD at UCLA in Biostatistics as well. My dissertation was on high-dimensional survival analysis. And I think as a statistician, when we take these classes, we typically, when we take intro to stat classes or intro to biostat classes, we sort of already have cleaned the data. So when we run our analyses or do the homework assignments, pretty much all we have to do is just fit the model, right? However, in real life, and what you'll see is that data typically are very messy. And so at least for me, for a lot of my collaborative projects that I do, 20% of my time is just the analysis. Like fitting the model isn't hard and it's not time consuming. What takes the most time for me effort-wise is actually getting the data and cleaning it. And so today I'll just be talking about one such package in R that sort of allows you to sort of easily clean the data. And we'll get started. If you have any questions, feel free to write it in the chat. George, if you want to just chime in with the questions, feel free to do that. So it's always hard as a presenter to simultaneously do the presentation and look at the chat. So if you want to just raise your hand or just tell me, hey, like here's a question, just let me know. So yeah, we'll get started. So what is data wrangling? So the Wikipedia definition of it, process of transforming and mapping data from one raw data form into another format with the intent of making it more appropriate and valuable for a variety of downstream purposes such as analytics. In layman terms, essentially, you want to make data easily accessible and readable. So before we talk about how to clean the data, first I want to go over a certain structure of data that you can find in R, which are data frames. So data frame is just simply a table or two-dimensional array, which each column contains values of one variable, and each row contains one set of values from each column. So for those of you who are a bit more mathematically inclined, you could think of this as like a matrix, like an n by p matrix with n rows and p columns. Data frames typically have the following sort of characteristics. Column names should be non-empty. The row names should be unique. So if you can think of this as columns being variables, predictors, covariates, variables of interest, whereas rows typically would be like samples, subject IDs, etc. The data stored in a data frame can be, it could be numeric, it could be factored, it could be a character type, which is what makes this a bit more flexible than a matrix, where typically in the matrix, they're all going to be numerical values. Each column should contain the same number of data items. And as I said before, all numerical matrices can be converted to data frames. However, not vice versa. So all data frames can't be converted into numerical matrices. As I said before, because the data stored in the data frame can be factors, blood type, cancer stage, etc. And those are more so characters than they are, or factors than they are numerical values. So here's an example. I think your first example that you had before, or your first session you kind of talked about ggplot2. Here's just the data frame you can get from ggplot2. It's the typically known as the diamonds data set. It's a pretty standard textbook data set that you'll see when it comes to trying to this, along with the iris data sets, are sort of used for like exemplar purposes. So you can easily load this, and if you want to do this along the way, you could feel free to open up RStudio and type in the commands I have here. But essentially, you can look at this diamonds library or diamonds data set. What you'll see here is just the first 10 rows of this data frame. And so what we have here is that we have 10 unique diamonds. And for each diamond, we have the following characteristics, right? So you have the 4 C's: carat, cut, color, clarity. You also have table, you also have depth, table, the price, which I believe is in dollars, and then X, Y, and Z, which I do not remember exactly what those are in terms of this data set, but essentially you can see here that for each row, you have entries of each of these values. The actual data frame is larger than 10. It's only showing the first 10, but it's actually about 54,000 diamonds that you have here. So the dplyr package is one package in R. Oh, I think there's a chat. Okay. So the dplyr package here is a good way to sort of do data wrangling. Typically, the data that we originally read in, whether you get it from a lab or you get it from some gigantic EHR database, it can't be readily used. For example, you might need to remove subjects that don't meet a certain criteria. You might need to create new variables that are sort of like functions of the existing variables in the data set. You might even just want to do something as simple as extracting summary statistics, whether it's unstratified or stratified by groups. And so a decent amount of time and lines of code, they're needed to ensure that the data are in the right structure before proceeding to the statistical analysis. Doing multiple things, extracting variables, creating new variables, subsetting the matrices, only getting a fraction of, of a certain group of, of patients, et cetera. And those things, doing them all at once can start to get complicated. So we also have to be wary about code readability. And so the question here is, can we clean and wrangle data using nicer syntax? When I was an undergrad using R, doing some projects, my R code would be like hundreds of lines long. And if I were to give it to somebody else, they wouldn't be able to read it. And in terms of reproducible research, that's a little challenging because you want to be sure that you know exactly what someone's doing when it comes to cleaning the data, filtering data, and so on and so forth. And before, actually, SAS was like one of the best statistical programming languages to clean data because it had a very simple syntax. And then R was a little bit challenging at first until the TidyVerse came, which is this gigantic suite of R packages, in which dplyr is one of them, and it sort of really made data wrangling and data management a lot easier to do in R. And so moving forward, a lot of people use dplyr almost like religiously in terms of cleaning the data. So what the dplyr package actually does is that it provides a set of what I would call verbs that help you solve most common data manipulation challenges. It's part of the TidyVerse, which is, ggplot's part of them. There's also a whole suite of other R packages I'll sort of briefly mention towards the end. And if you want to, there's this cheat sheet. If you just click on this link, which I think you have a link to the slides, so you can easily look at these again. But this PDF here sort of gives you a cheat sheet of commonly used data wrangling verbs. Today, I'll just be talking about a few of them. There's so many of them to go over. It's easily a 3-day workshop in and of itself. But for the next 40 minutes, I'll try to only go over the most commonly used ones, at least for me, that I use the most. And that's going to be the following, which is select, filter, mutate, summarize, and group by. And I'll just basically be talking about each of these. And then again, if you wanted to, feel free to, do this along the way, open up RStudio, type in the code that I had, and just sort of work on this. And we could work on this together. I think that's the best way to learn. So we'll move forward. So first, let's install it. If you haven't already installed the TidyVerse, if you already did, you're good to go, which you might have done day one because you use ggplot2. But if not, you can easily just install the package in R. Just by typing install.packages, dplyr in quotations. And then once all that's done, just type in library dplyr to have it loaded onto your R session. So we'll talk about select, which is the first of the verbs that I'll be talking about. And what select does is that it's basically, you can think of this as subsetting the data column-wise. The select function allows you to select columns or variables in the data frame. And the syntax is as follows. So the syntax would be select x comma y. There'll be 2 arguments. And this is equivalent to saying something along the lines as select variable y from data frame x. Note that here y can be a vector of column names. or their numerical positions in the data frame. So you can look at it. So I believe for the diamonds, I think caret was the first the first variable in the data frame. So if you want to do like select diamonds caret, that works, or select diamonds 1, since 1 was indexing the first column, which is the caret variable. So an example here in action is that we're just going to be retrieving both caret and price for each of the diamonds. So you just type in select. Again, the first argument is always going to be the data frame of interest, in this case, diamonds data frame. And then we're going to be just exporting out both caret and price. And when you do this, it returns the data frame again. And so here you can basically see it's the same 54,000 diamonds that we had before, but instead of having 10 variables, we only have 2, which is caret and price. And so that's how you kind of use the select verb. So just kind of an example that I want you guys to try to do. If you have time, or you can do this in your head, or you can actually do this in R right now quickly. But the exercise is just creating a data frame, which I would call diamonds underscore 4C. That contains the 4 C's, which are cut, color, clarity, and caret. And so just a quick little hint, to define a data frame, you just type in, this, which is sort of assigning to diamonds underscore 4C something. And here is what where I'll let you sort of take some time to think what you're going to put over here to basically create a data frame that contains only the 4 C's. Again, maybe like 10 seconds. You guys can think about it in your head, or if you're going to do it in R, you can feel free to do it. All right, I think that was enough time. If not, feel free to just keep on working on it. But the way you do this is as follows. You just do diamonds underscore 4C, select diamonds again, that's the data frame you want to look at. And we could just type in cut, color, clarity, and caret. And in doing so, we're assigning 2 diamonds 4C this data frame over here. And so we could see here when we actually call diamonds underscore 4C, we see exactly what we want, which are the 54,000 diamonds, and we get the cut, color, clarity, and caret. And this is, of course, going to be the same order as you sort of defined up here. So next, so that's select, right? It is what it's saying, right? You just basically are selecting columns. The next one is filtering, which is sort of, like subsetting the data row-wise. The filter function here allows you to extract rows that meet some logical criterion. Again, if you look at the verb filter XY, extract the rows of X where Y is true. And this is where you're going to have to come up with some logical arguments as to how you're going to be filtering the data. For example, let's say you're only interested in looking at diamonds that are less than $100. I'm not sure there's any in this data frame because I don't think diamonds can go that cheap. But if you want to look at that, then essentially you'll just filter from diamonds where the price is less than 100. And what it's going to do is basically say, okay, I'm going to look for basically what it's doing internally is saying, okay, let me find all the rows where that criteria is met. Sometimes it might be empty and you'll get like an empty data frame, nothing would be there. Or sometimes, or you'll get like maybe the subset where that's true. And this is usually kind of important when you're trying to include or exclude subjects from a certain analysis, right? So if you're running an analysis and you're only looking for maybe the sickest patients, right? Like maybe those who have cancer stage, 3 and 4, then you want to maybe filter out so that you only find those people who meet that criteria. Maybe you're only looking at specific gender, maybe male or maybe only female. And so you want to do that. Maybe you want to filter out or trim outlying values. So if there's a BMI greater than, I don't know, like 500 for some reason in the data frame, and we could just exclude that by making these little flags. And so this is a very important one, especially for me when I'm working on a lot of studies where, we're only looking for a subset or a subgroup of population. So we would sort of, create these flags to make sure we get exactly who we want in our final analysis data set. So in action, this is how it's going to look. So I'm looking for diamonds with a price that's less than or equal to 2,000. So if it was strictly less than, then you wouldn't have the equal sign, but since the equal sign is here, we're just looking at less than or equal to $2,000. And what we do here is that what we can see, again, we have all 10 columns in the data frame. I didn't subset or select any columns, remember, I'm looking at the entire data frame. But we could see that that original number of diamonds went down to 24,000. And the reason why is because we're only looking at diamonds that meet this criteria. So if we actually look at all the prices here, it's hard to tell because these prices are obviously a lot smaller than 2,000. But if you wanted to look at this in R, you can verify and see that the only diamonds that are kept in this data frame are those that had a price that's less than 2,000. And again, just like the select, remember we could do multiple arguments for select, like you want to select 2 or 3 variables. You can filter off multiple variables as well. I'm doing the same sort of syntax. So here's just going to be a very simple example. So suppose a customer arrives at your store and they want only to look at your finest diamond. So you have this whole data frame of diamonds, we got like 49,000. But this customer is only interested in looking at what I would call the finest diamonds, all right? And let's say that after talking to them more, you realize that their criteria includes diamonds that are both ideal and cut and internally flawless in clarity. And so you don't want to manually look through all 49,000 diamonds and try to find the ones where these are met, right? You can easily use R to clean the data to find the list of diamonds that actually meet this criteria. So, just like the first example, just like in the first example, I want you all to sort of create a data frame, which I would just call diamonds_fine, that contains all diamonds that meet these criteria. Now remember, there are 2 criteria, right? There's one where we want ideal cut, and then the other is that we want clarity to be internally flawless. So we'll just maybe give a few minutes to sort of, or maybe like not a few minutes, maybe like a minute or so to kind of think about how you do this. You're going to be using the filter command. Obviously, the first argument is going to be diamonds because that's data frame of interest. But what are going to be the 2 arguments you're going to be putting in there so you only get the diamonds that this customer is looking for? Okay, so I hope you guys had a little bit of time to think about this. George, sorry, how much time do I have? I don't know when this is supposed to end. 12:30?
Should be, yeah, that's right.
Okay, yeah, I'll probably be done, way earlier than that. So if you guys have any questions, feel free to keep them for later, or just ask them right now. So the way you do this is going to be kind of simple. Here, diamond_fine, that's what we want to create. And to this, we are assigning the following data frame. Again, diamonds is what we're looking at. And to look at having both an ideal cut and clarity being internally flawless, we're going to have the following logical arguments. The first is that the clarity has to be equal to internally flawless. And if you remember in R, the double equal sign is denoting equality, since the single equal sign typically is used for assigning variables. So logically, you want to look for clarity equals to internally flawless, and simultaneously you want cut to be ideal, which is what this AND operator is doing. If you change this AND operator to a vertical line instead, that's usually going to be the cool. Yeah, so that's just me being lazy. You could do both of them having parentheses, or none of them having parentheses. I just sort of had this here. I should have been more consistent, so I apologize. But you could remove this and you'll get the same answer, or you could include the parentheses over here and you can get the same answer. Typically, I like using parentheses because it kind of separates the logical arguments. You're looking for clarity equals list, that's one thing, and then cut equals to list, and that's another thing. But I sort of just, you know, I forgot to put them on here. So I apologize for that. But including them or excluding them, you'll get the same results. But again, so the AND operator here is just saying that both of these have to simultaneously hold. If you change this to the vertical line operator, which is above the enter or return key, that's going to be the OR operator, which is saying only one of them has to be true. So obviously, an OR operator will have more trues than the AND operator, because you're only looking for true. You're only looking for one of these conditions to be met rather than both being met. But anyway, you know, I digress. I apologize. But for here, if we look at this data frame, then we can see that this data frame itself, again, we have all 10 columns: caret, cut, clarity, depth, price, table, X, Y, and Z. But we can see that it's shrunk dramatically. So instead of having like 40,000 plus, we only have 1,200. And if we look further here, we can see that the cut here is all going to be ideal, and then the clarity is all going to be internally flawless. If you look at the other 1,200 rows, you'll also see that as well. So this is great, right? Like, let's say you're a diamond handler, manager, gemologist, and you know you're trying to sell diamonds. Instead of having to look through all 40,000 of them, now you only have to look at 1,200 of them, right? Like, this is going to be good for you because you don't have to spend so much time filtering out what is what is the diamond, like what kind of diamonds is this person looking for or not. You already can do it manually, or you could do it, sorry, not manually, automatically using this filter command. So, you know, again, select is to select columns. So subsetting the data column wise. Filter typically is to subset the data row wise. So kind of like applying exclusion or inclusion criteria, however you want to see it. The next one that I want to do, that I want to talk about, is the mutate command. And as it suggests, you're basically mutating a certain variable. So you're changing or creating a variable. So we can change or create a variable using the mutate function. This typically is what I would use whenever, you know, a collaborator is like, you know, here are two outcomes that I'm interested in, but I want to look at like a function of the two. So I want to look at like the mean value of the two, or I want to look at like this value squared, or this value reduced by 10 or something. And you know, you can easily do that by just creating a new variable. So you do that using the mutate command. Again, the first argument here is almost always going to be, or you want to clean the data. And so here, the mutate command here, again, the first argument is always going to be the data frame of interest. And then the second one is going to be sort of the argument that you're looking at. Again, the second or third, it could, just like select or filter, you could do multiple at the same time. And so what this is saying is you're adding column Y to data frame X, where Y equals some argument. If Y already exists, then it's essentially just replacing Y with whatever argument that you're stating here. And again, you can change / create multiple variables using one pass of mutate. So you don't have to do mutate this, and then mutate again, and then mutate again, and mutate again. You could just do one mutate with several different arguments. So here's an example of that. I am, looking at that 4C data frame, the one that only had cut, color, clarity, and caret. And let's just say for some reason you wanted to square the caret value, or you wanted to cube the caret value. Then what you would do here is you just do caret squared or caret cubed. But then you need to name them. So I'm going to name this caret underscore squared. You can name this caret underscore sq, caret.sq, caret2, whatever you want to name it. But what I'm saying is that this variable I'm going to be creating, and what it's going to be doing is just squaring caret. Same thing for caret cubed. And what we can see here is when we get this data frame again, we had those first four that we had before: cut, color, clarity, and caret. But now I also have these two additional columns, each one corresponding to one of the functions that I wanted to do. So caret squared is going to be obviously list number squared. And then caret cubed is going to be list number cubed. And so that's how I'm mutating the variables. If I wanted to do other ones like caret over 2 to do like a half a caret, or anything like that, then I can also easily append those here too. But essentially, you're just adding or creating new variables. You can also change variables that are already existing. So that's what I'm doing here. Remember, clarity before was under these different labels, SI2, SI1, VS1, VS2. I think it was like slight inclusion. I forgot. It's been a long time since I bought a diamond, but they're basically ranking how clear the diamond is, if there's any sort of occlusions in there or not. And so they're ranked kind of like from like a good, kind of like from like a bad to good rating. But this is all in terms of, you know, the labels in terms of words, or, you know, like an alphanumeric labeling. Look, let's just say I want to look at this strictly as like 1, 2, 3, 4, 5, which will give you the same thing, right? Assuming 5 is like really good and 1 being poor, you know, they kind of have the same sort of interpretation. What you could do here is, well, then you can just look at clarity, and you could just change that variable. So before it used to be VS1, VS2, SI1, SI2, and I'm just creating it to be numeric, where I'm just basically converting that into a numeric value, going from 1 to 7 or however much there is. And so we can see here that clarity, you know, it's just being replaced. I'm not creating a new variable called clarity. I'm just replacing the existing variable called clarity just by creating those into numeric values instead of like an ordinal factor. And that's what's going on here. So this is an example of replacing an existing variable, whereas before this is creating a new variable. So just you know, give you guys another example here that you can kind of play around with. But suppose, you know, let's say you have a buyer in Japan who's interested in purchasing diamonds from your inventory, right? So you know, an employee sends them over the list, and by your enthusiastic request to purchase your entire inventory, and you feel very happy about that. But then you realize that the reason why is because the employee forgot to convert the prices from USD to yen, and you know, 5 yen is really, really cheap. So they would of course buy all your diamonds if you're pricing them as yens. If your USD were being thought of as yens. So what you want to do now is say, okay, well, whoops, let me create you a new data frame that gives you the actual prices, not the prices you think they are. So you're going to create a new data frame, diamond underscore yen, that essentially will replace the variable price with the price in Japanese yen. For example, here, 1 yen is equivalent to 0.0094 USDs. And so a hint here in terms of the conversion is that 1 USD is going to be equal to about 107 yen. I wrote this in 2020. It could have went up or down, but for now, let's just assume that this is going to be the exchange rate. So I'll give you guys maybe a few minutes again, or a minute again. Think about it in your head or do it in R. But just, you know, how would you change that price variable to reflect the price in terms of yen than it does in dollars? All right, well, hopefully that was enough time. So the way you'll do this is just as follows. So diamonds, again, data frame of interest, but we're going to replace price with 106 times 0.60 times the original price variable, since the prices were already in US dollars. So now when we look at diamonds underscore yen, the prices here are going to reflect the price of the diamond, but in terms of yen instead of US dollars. And you can see there's a big difference between 34,000 yen and 3,000. So this is kind of like important as to why you want to use the mutate variable to sort of change the price. If you wanted to, you could do this. You know, you could have created a new variable, right? If you want to make sure you keep the list in terms of all types of currencies, you can just create one for price, and then you could have easily done price underscore yen right here, and then it would have, instead of replacing this, it would have just made an additional variable. That way you kind of have both as a side-by-side comparison. But which might be something good if you want to look at this with multiple currencies or, so on and so forth. So that's an example of how to use the mutate command. We have two more left, summarize and group by. Group by is kind of like a supplementary verb, but the summarize verb is kind of good in terms of summarizing the data. Typically, most of you are probably, going to be doing some basic simple summary statistics, looking at means, medians, IQRs, min, maxes, very simple things. And, typically these can be seen as like table ones, right? In terms of an analysis or a paper, kind of like describing the cohort. So you can use the summarize command to do exactly that. And it creates a new table of summary statistics. So essentially we'll map whatever vector you have of n items into one. And the way the verb works is summarize xy, x again, as always, is the data frame of interest. And then y is just here saying you're going to apply f to the variable z in x and call it y. It's a bit hard to explain, but some examples here can be like the sum, the mean, the median, the min, the max, which are all already in R. And you can also use user-defined functions. As long as it takes in a vector and return to scalar, you can use user-defined functions to also summarize the data as well. And then summarize with the Z is what I'm using, but also summarize with an S, I believe, also works just as well. So here's an example of this. So let's just say I look at the average price of all the diamonds. Then I'm summarizing from the diamonds data set. I'll be calling this column average price, AVG_price. And what it's doing is it's getting me the mean of all the prices. So of all, I forgot how 54,000 variables that we had, I'm basically, summing up all the prices. I'm summing up all the prices and then just dividing it by 54,000. That's giving me the mean. I could have easily done like MED_price. I want to look at the median, min price, I want to look at the min, so on and so forth. And so that's one example of using an already defined function. So here is mean. You can also use a user-defined function. So here I'm going to be first defining a function that I'm calling sum of squares, which is basically, taking the sum of the squares of the value of the vector x. And what I'm doing here is now I could use the summarize command again, and then I can get the sum of the squares of the price. I'm not sure why you'd want to do this. I don't know why the L2 of this vector means anything, but if you wanted to, you can do it. And you can just call SSQ because it's already been defined, and then the price. So you're just looking at the sum of the squares price, and I'm going to be calling that column SSQ_price. And that's what you get here, this gigantic number. And again, just like the other verbs, you can do multiple at the same time. So if I want to look at min, median, max, all at once, and you'll just, comma min price equals something, comma max price equals something, comma mean price equals something, and so on and so forth. Yeah, and then that's what I have here, right? So you can do mean price, median price, and now I have two columns, one for the mean and one for the median. So here again, just to this was a very simple explanation of the summarize command. It takes a vector, returns a scalar value. Remember that this actually disregards the other variables in the data frame, right? When I'm looking at the price, at the average of the price, I'm literally taking all 54,000 prices and getting the average. But sometimes, they might not be interested in looking at just the whole average. Maybe we want to look at the average within groups, right? So we might be interested in looking at group specific summaries. So for example, let's say we want to look at the average price, but we want it to be based on cut, right? There's like a few different cuts and we want to find the mean within each of these groups. How do we do that? And that's where the group by command comes into play. So with the group by command, we specify the variable that we want to, no surprise, group by. So then now any functions we apply via summary or summarize will be based on the following grouping. So here's an example. I'm going to first create this variable diamond_cut where I am grouping the diamonds data frame based off of cut. And then now I want to summarize it so that I want to get the mean price, median price. So this looks almost entirely the same as what I did before. But because the data frame that I'm looking by is a grouped data frame, it'll actually do this based off of the cut. So instead of having, so here we can see that there are 5 different cuts going from fair to ideal, ideal being the best. Or sorry, I forgot exactly what the ordering is. I'm assuming the price will help with that. But we can see here that, I'm getting the mean price based off of all the fair cut diamonds. I'm getting the median price based off of all the fair cut diamonds. For the good, same thing, getting the mean, getting the median. For very good, for premium, for ideal, the same as well. So this is giving us group specific summaries. So this is something, maybe you want to look at a study and you want to see time to death, or time to mortality, or mortality time for patients within specific cancer groups, right? So stage 1, stage 2, stage 3, stage 4. So you can, first group that data based off the stage, and then you can find the median survival time, mean survival time, or restricted mean survival time, sorry, and so on and so forth. And then when you do that, you're going to be looking at that based off of the different stages. So that kind of will be more informative than giving you the average over all the groups, because we would expect those in a higher cancer stage to have a lower survival time than those who are in a less severe stage, like stage 1. And so that's sort of telling you something about the data, kind of giving you a story. And that's more important than just getting the average or the median over every single subject in that study. You can apply more than one transformation. So everything that I've done before here, using the group by, summarize, mutate, filter, select, they're all basically, I'm doing one transformation and that's it. But oftentimes one transformation won't suffice. We want to do multiple transformations to the data, right? We want to, subset by a specific, we want to subset the data. We want to only get a few columns. You want to create a new variable based off of this column. You're going to be doing a lot of things at the same time. And so how do we do that? So for example, let's take the first 2 examples, right? We created a data frame. First only has cut, color, clarity, and caret. And then we also filtered based on cut being ideal and clarity being internally flawless, right? Those are the first 2 examples that I showed you. So how would we do both at the same time? The first naive solution is to create many data frames, right? So we do step 1, this is essentially what I got before, right? I am, getting diamonds underscore 4C, and I'm selecting from the diamonds data frame, cut, color, clarity, and caret. That's step 1. Step 2, okay, now I'm going to filter, from that data frame that I just defined. I'm going to filter to only look at those with the cut being ideal and the clarity being internally flawless. And I'm going to call that diamonds underscore sol 1 or solution 1. So now when I look at that data, it's going to be only the 4 C's and only looking at ideal and internally flawless. So that's step 1. That's the naive solution number 1, which is to just do each one line by line. The second naive solution is to do a nested data frame. Now remember that these here are data frames in and of themselves. I'm only assigning them to a variable to preserve this data frame, but you can actually just nest these data frames together. So the second solution is essentially taking the first 2 solutions, is basically replacing this in here. You could think of it as like a variable substitution, right? Instead of going to this step, you just automatically put this into here. Instead of, it saves you 1 step by saving you 1 data frame worth of memory. And so now diamond underscore sol 2 will give you the exact same data frames. So if you look at this data frame and this data frame, they're exactly going to be the same. And they're doing the same exact thing. But that's naive solution 2. And there's a reason why they're called naive. So applying more than 1 transformation, both are correct. And we may be able to get away with it for 2 transformations, but how about 4 or more, right? Do you want to really create 4 nested data frames? Or do you really want to create 4 or 5, temporary data frames to only be used to create a final data frame? Like, it seems like a lot of work and a lot of code. If you were to write this, it's going to be this gigantic, chunk of code. And, is there a way we can kind of simplify this, making it easier, making it more readable, making it cleaner? Is there a way to do this doing multiple transformations? And fortunately there is, and it's called the pipe function. So the pipe function is essentially a transformation of a data frame to another data frame. You can think of this very simply as a mathematical function. Again, for those who are mathematically inclined, this is kind of like doing like a compositional function, right? So you're looking at z equals x of f. So what you're saying here is so this line of code here is the same thing as saying apply f, this function here, to the data frame x and then call that z. We can even pipe consecutively. So we can like, this can be like an intermediate, this is the initial step, this is the intermediary step, and then this is the final, this is the data frame you wish to apply that on and get a final data set. So here's a question, but what about the data input for the dplyr function we learned, right? So the good thing here is that the pipe function is specifically built to use the data frame from the left-hand side. So remember how we used to say select x comma y, right? Select diamonds, comma, cut, color, clarity, and caret. With the pipe function, it's already assuming that you're using the diamonds data frame when you're piping. So here I'm using diamonds, and within diamonds, I am going to be selecting y, which is only going to be cut, color, clarity, and ideal. I'm omitting that first argument because it's already assuming that I'm using the data frame that's from the left-hand side that we see here. So here is that same exercise revisited, where we want to select only cut, color, clarity, and caret, and we want to filter based off of internally flawless clarity and ideal cut. And the way you can do this is you can pipe twice. So the first one is we can look at, here's the diamonds data frame, and within diamonds, I want to pipe and say, select these 4 variables. And then I want to pipe again and saying, then filter these variables. And then I'm going to save all this into one data frame, which is diamonds underscore solution 3. And so again, if you were to read this data frame, it'll be exactly the same as those first 2 solutions that I showed you. Well, this looks a lot nicer, in my opinion. It looks a lot nicer doing this than it does doing this or doing this. Especially when you are going to have like 5 or 6 or 7 or 8 different transformations, you can easily just pipe another one, pipe another one, pipe another one, pipe another one. And you might be wondering if order matters here. And sometimes order will matter depending on, thinking about it logically, what you're doing from the top to the bottom. In this case, it doesn't really matter because these 2 are sort of like independent from each other. So you can filter first and then select, or you can select and then filter, give you the exact same solution. Here's another one. Where I want you all to kind of understand, kind of think what this is doing, right? So just take a minute to think about what exactly is going on here. All right. So we'll just talk about it quickly, so I'm kind of running out of time. What we're doing here is we're getting the diamonds data frame, we're grouping by cut, and then we're summarizing, we're creating a new variable, average price, which is the mean of the price values, and then we're arranging the data. I didn't teach you this one, but we're arranging the data based off of descending order. So from highest cut to lowest cut, so from ideal to fair. So we can see that that's exactly what this data frame is doing. We're grouping by cut, summarizing it, and then arranging it. You could have done this in 3 different data frames. You could have done this in one nested data frame, but I feel like this is a lot easier to read than doing the other two alternatives. So here's a final exercise. Think about this again, or do this, do this on R right now if you want to. But just think about what you learned before with ggplot2 from your first session on Monday. But suppose we're interested in plotting the average price of diamonds by clarity in terms of the price in Canadian dollars. Remember here, 1 USD is equivalent to 1.33 Canadian dollars as of 2020. Create a data frame that contains, step 1, create a data frame that contains the mean price of diamonds in CAD based on their clarity for diamonds that meet the criteria below. You only want to look at diamonds that have a carat greater than 1. You want to look at diamonds with a clarity greater than or equal to VS1, and where the cut is at least good. And then use this data frame to produce a plot that plots the mean price by clarity. So this is where you're going to be using ggplot2. So this part is all going to be what I taught you over for the past 30 minutes, 40 minutes. And then this is just going to be using that data frame that you created, now plotted. Let me see if I have. So here's a hint. Okay, here's a hint of how you're going to be doing all that. So you could call it diamonds_final. So from diamonds, you have basically 4 piping expressions. You have 1 mutate, 1 filter, 1 group by, and 1 summarize. And then using diamonds_final, you can plot the data. So what would you use for your X input? What would you use for your Y input? I'm leaving that blank for you all to do. And then here's how you can create the labeling for the X and Y axis, and here's how you can get that scatter plot. But again, just to reiterate, the mutate, filter, group by, summarize, you want to, you want to contain the mean price of Canadian dollars. So first, you're going to mutate the variable to get Canadian dollars. How are you going to filter the data so you can get the diamonds that meet these exact criteria? And then again, we want to find the average price of the diamonds, but we also want to find them by a specific variable, which is clarity. So, doing like a subgroup, basically creating the means based off of clarity. So, you're going to mutate something here to get Canadian dollars, something here to meet the criterion of what diamonds we're going to be looking at, grouping by clarity, because clarity is what we want to look at, and then a way to summarize to get the mean price. So I'll give you guys maybe 2 minutes for this one, because this is a bit more involved. Think about what you're going to be doing. Do it. If you are in R right now, feel free to try to do it on your own. But I'll give you maybe like a minute or 2 to think about this, and I'll give you all the solution on how to do this afterwards.
And while you're doing that, just to remind you guys that, so the dplyr is just one way to manage the data. In the case that you are handling like really big data, you can always also use the data table package. I'll just put it in the chat, which was built for managing large data set and for speed. But that said, there's also the DTplyr package that makes a bridge between data table and dplyr. So if you're used to like using the dplyr verbs, you can always use but you want to have like do more heavyweight lifting with data table, you can always use the DTplyr package.
All right, hopefully that was enough time. If not, and you want to challenge yourself, feel free to mute the next minute or 2 as I go over the solution. So again, here was sort of the hints on what you wanted to do. So the first thing you want to do here is create Canadian prices. So CAD, I'm going to create a new variable. Instead of replacing the price variable, call this 1.33 times price, since what I said here, based off of this information. Filtering, so I want caret to be greater than 1. I want clarity to be greater than or equal to VS1. Again, I forgot to sort of mention this, but the reason why this logical value works is because these are ordered factors. So there is an ordering naturally mathematically that's being counted here. If these are just character strings, you wouldn't be able to do this because it wouldn't make sense. And then you want cut to be greater than good, again, because this is an ordinal factor. So I'm filtering the data to make sure I only get the caret. I only get variables or diamonds that have caret greater than 1, clarity greater than VS1, and cut greater than good. I want to group by clarity, and then I want to summarize by creating the average price, which is the mean CAD, because I was interested in Canadian dollars, not US dollars. And in doing so, you get the final data frame, which is just a 4x2 data frame, where the 4 clarities, and then the average price of the diamonds within those clarities by Canadian dollars that are meeting a certain criteria. And then the way you'd plot them is you would do ggplot, diamonds final, X equals clarity, because that's our X axis of interest, Y being the average price in Canadian dollars. I'm going to look at the points. So here are the points up here. And then I'm just relabeling the x-axis. So the x-axis is clarity, and then the y-average is average price and CAD. You can do this. You can change this to any other price you wanted to. So if you're going to do the yen example, you could do the yen example. If you're going to do some US dollars, you can do some US dollars. But that's sort of how you would plot these. So parting comments. So dplyr, to me, in my opinion, it's a necessity for data management, manipulation, and cleaning. It makes it a lot easier. When I did this in undergrad, it was so much harder before I found out about dplyr. And when I found out about dplyr, my life got like exponentially easier in terms of data cleaning. We learned some of the most popular verbs that dplyr has to offer: filter, select, mutate, etc. But there's several more that I didn't include. For example, the arrange one that I sort of went over briefly. But there's a lot, and it's hard to kind of go over that in an hour, right? I already spent an hour, and I only went over 4. Anything else? So some other parting comments. There are several other functions in dplyr I haven't talked about. If you look at that cheat sheet that is in the actual slides, you'll find, again, some more popular ones that people do. There are other packages that you might want to be looking at too. So here's dtplyr, which is basically dplyr for data tables. So this is typically good for larger, high-dimensional big data frames. The data frame that I had, which is only 54,000 subjects, some may consider to be small, some may consider that to be large. But dplyr working for this, but for larger data frames, especially for bigger EHR data sets or even genomics type of studies, you might want to use the dplyr instead of dplyr. Stringer is another good one. It's a supplemental package that allows for string manipulation. So if you want to subset strings or replace strings or delete strings, this is a good way of doing it. TidyVerse, which I would use to convert data frames from wide to long format, which is helpful for longitudinal type of studies. And then again, this is all part of TidyVerse, which is a suite of R packages developed to make data wrangling, manipulation, and visualization easier. And that's the end of this bootcamp. There is some appendix here, but it's not really important. It's for you all to kind of have a better understanding of what's going on internally versus doing it manually using base R. And again, all the things you have here can be done in base R. Base R, I mean, not using dplyr, it just, again, it'll just be kind of unmanageable and challenging. So I'll leave it at here. If you have any questions, within the next 3 minutes that you have, feel free to ask them.
Thank you, Eric. This was great. So remember that tomorrow will be our last day, and we will have Eric again, who will be telling us about R Markdown, which is what we actually use for making this presentation and Monday's presentation.